Today we're going to talk about the derivative of the sine of x function and the derivative of the cosine of x function. Now I want to start out by looking at a graph of these functions. This is the graph of the sine function and the cosine function. So if we look here, the red graph is the sine function. And we're just going to start here where the sine function is 0. The next place that the sine function is 0 is down here. So we're going to look at this area between these two zeros of our function. So first of all, we know sine of x is 0 at this point and at this point. So when I look at this, if I look down and crossing the 0 is the cosine function. It crosses 0 at each of the points that sine of x is equal to 0. This derivative of sine of x is equal to 0. So, and then if we take a look at between our two zeros, what's happening to our function here? It is going downhill. So the function is decreasing. And if we look at the sine graph between, if we look at the cosine graph between these 2 points, it is negative. It is below the x-axis. So if we can look at these points and what happens on the cosine graph, the derivative of the sine graph is cosine. It goes through the x-axis everywhere that sine is 0, the slope of sine is 0. When the slope of sine is decreasing, the cosine function is below the x-axis. When the slope of sine is increasing, the cosine function is above the x-axis. It is positive. So we can see that the derivative of sine of x is modeled by cosine of x, which brings us to our first rule. Our first rule, the derivative of sine of x is the cosine of x. So now we're going to look at what is the derivative of cosine of x. And we might guess, well, maybe it's sine of x. So let's go ahead and look at our function, the graphs of our functions. So here's our graphs again. Here we're going to look at our cosine graph. So let's look right here. The cosine graph is 0. And indeed, the sine graph is going through 0. So we think, well, maybe this is going to work. So again, our cosine graph here is 0. And our sine graph is going through 0. So let's check now to see what's happening from 0, where our slope of our cosine graph is 0, and where the second 0, where the slope of our cosine graph is 0. Between here and here, we are decreasing. But if we look at the sine graph, what's it doing? It is above the x-axis. So that would mean it was increasing. So even though my zeros line up here, between here and here with the zeros of the sine function there, sine of x is not the derivative of cosine of x. So we're going to look at another graph now. Okay, so we're going to look at this graph here. Our cosine of x in the pink and negative sine of x in the black. So again, we're going to look at our zeros for our cosine function are here and here. And the sine graph crosses the x-axis at each of those places. So between these two zeros, my cosine graph is decreasing. So what I would expect the negative sine of x graph to be below the x-axis, and it is. So between this second zero and the next zero, my graph is increasing. So where is the sine? It is above the x-axis. So that brings us to our second rule. The derivative of the cosine of x does indeed equal negative sine of x. Okay, and we will come back next time and we will talk about the tangent, the derivative of the tangent of x function.